All right, good evening or good morning, depending on what time it is you are watching this Edpuzzle. So, up to this point, we've been talking about adding, subtracting, multiplying, and dividing rational expressions, right? And remember, rational expressions look like a ratio of polynomials. So, we have a polynomial over another polynomial. That's a rational expression. So today, we're taking this to the next step, and we're going to be talking about solving rational equations. So by the end of the day today, or the end of this video, you should have a general understanding and be able to solve rational equations with one variable. So keep in mind, we're talking about one variable. So we're solving for x, or we're solving for y, or n, but we're not solving for multiple variables yet. The second thing that you're going to be able to do is identify extraneous solutions to rational equations and give examples of how they might arise. So as a review, we are looking at 1/2 x plus 2/5 equals 9/10. So there are two ways of solving these equations. One is my way, Mr. Evenson's way, and the other is Eve's way. So let's take a look at it into these two examples of solving. So in my example, we're solving for x. So we begin by subtracting 2/5, which if we want to convert to have a common denominator over here, we multiply by 2 over 2, right? So that ends up giving us 1/2 x equals 9/10 minus 4/10. So as we subtract then, that gives us 1/2 x equals 5/10. Now if we multiply both sides by 2 to get x alone, we end up with x equaling 10 over 10, which also equals 1. Now what if instead of just solving for x, we used the least common denominator as a factor of this? So when we look at 2, 5, and 10, we can see that the least common multiple and the least common denominator is going to be 10, right? Because we can multiply the 2 times 5, and we can multiply the 5 times 2, in which case everything would have a common denominator of 10. So as a result, we multiply both sides by that common denominator, right? We multiply each side by the least common denominator of 10. So as we factor this through, that's 10 times 1/2 x, so you end up with 5x, and 10 times 2/5 x, so that's the 10 turns this into a 2, gives us 4. And over here, the 10s cancel out, which leaves us with 9. So now we have 5x plus 4 equals 9. We subtract 4 from each side, gives us 5x equals 5. Divide both sides by 5, leaves us with, again, x equals 1. Now, either method is correct. You can use either one of these to solve. But going forward, as we're looking at this in terms of these rational equations, we're going to want to focus on using the least common denominator method. Finding the least common denominator, multiplying both sides of the equation by that least common denominator, and then solving for our variable. And remember, just like has been a focus and a cardinal rule of algebra, whatever we do to one side of the equation, we have to do to both sides at the same time. So this is the least common denominator, or least common multiple method. So let's take a look at a couple of examples. So if we're going to solve 1 over x plus 4 equals 2, I want to use the least common denominator. So we have x plus 1 on the one side, and we have a 1 on the other. So my least common denominator here is going to be that x plus 4. So we want to multiply each side of the equation by that x plus 4. So let's see what happens there. If we have x plus 4 times 1 over x plus 4 equals 2 times x plus 4, that x plus 4 is going to cancel out on the left side, leaving us with 1. And that's going to equal, once we distribute that 2x plus 8. So at this point, these are problems and equations that we've seen dozens, hundreds, thousands of times, right? So at this point, all we need to do is subtract 8 from both sides. That leaves negative 7 equals 2x. Divide both sides by 2. X is going to equal negative 7 halves. So, example number 2. When we take a look at this one now, we want to find our least common denominator again, right? We have x minus 3 on one side and 1 on the other. So our least common denominator is going to be x minus 3. So if we multiply both sides by x minus 3, right? 5 times x minus 3. So again, those are going to cancel out, leaving us with 1 on the one side. We need to distribute our 5, so that's 5x minus 15. We're going to add 15 to both sides. Gives us 16 equals 5x. Divide both sides by 5. X equals 16 over 5. So now what if we add an extra element here? So now instead of just having one expression, one rational expression, we have 2. So we have 1 over x plus 2 over x equals 1 over 6. So what is my least common denominator here? So we have an x and an x. So those both have a common denominator of x. So we know we're going to have an x. Now on the right-hand side, we have a 6. So in this case, we have to have a 6 and an x, right? Because this one is missing a 6, and this one's missing an x. So that way, all of them would be 6x. So our least common denominator is 6x. So we're going to multiply both sides by 6x, right? So that's 1 over x plus 2 over x equals 1 over 6 times 6x. So in this case, we're going to distribute. So 1 over x times 6x, that's going to leave us with 6, right? Because that would be 6x. Let's write it this way. 6x over x plus 12x over x equals x. So we can simplify by crossing out those x's. So that's going to leave us with 6 plus 12 equals x. So x equals 18. So what if we plug in that 18 back into our original equation? Let's see if it's true. We have 1 over 18 plus 2 over 18 equals 1 over 6. So that's 3 over 18 equals 1 over 6. Yep. So that checks out. That is one of our solutions. Now, sometimes when we're solving these equations, we are going to run into what's called an extraneous solution. So what is an extraneous solution? That's a solution that you find, right? It's a correct solution based upon the math. But that solution cannot be a real solution, because it makes the value of a denominator in the original equation equal to 0. Saying that another way is that if we get a solution that would make the original function undefined, then that solution is an extraneous solution and not a true solution of the equation. So let's take a look at this one as an example. So we have 1 over 5 minus x plus x over x minus 3 equals 2 over x squared minus 8x plus 15. So the first thing we want to do when we look at this is we want to make sure that we find the common denominator. So I want to start by factoring this one. And so I'd use my x, that's 15 over negative 8. So that would be negative 5 and negative 3, right? Because negative 5 times negative 3 is 15. Negative 5 minus 3 is negative 8. So we have x minus 3 and x minus 5. So looking at that, we already know what is our domain here. Our domain is that x cannot equal 5, because 5 in that first one would be 5 minus 5. That would make that undefined. It also can't equal 3, because in that case, that would make the second element undefined. And either one of them would make the third part undefined. So we know our domain says that x cannot equal 5 or 3. So now we've figured out our least common denominator, right? It's x minus 3 times x minus 5. So we're going to multiply both sides by x minus 3 times x minus 5. So we have x minus 3, x minus 5 times 1 over x minus 5 plus x over x minus 3 equals 2 times x minus 3, x minus 5 over, and I'll write it the same way, x minus 3 over x minus 5. That's our factored form right there. So we're going to multiply this by both. So that's going to leave us with x minus 3 times x minus 5 over x minus 5 plus x times x minus 3 times x minus 5 over x minus 3. And then on the right-hand side, I'm going to simplify already by saying that's going to equal 2. So let's simplify this further. We have an x minus 5 and an x minus 5, so that leaves us with x minus 3, plus the x minus 3's cancel out. That's going to be x times x plus minus 5, all equal to 2. So we have x minus 3 plus, we distribute the x squared minus 5x equals 2. So I'm going to rework this and combine like terms. So this is going to give me x squared minus 4x, right? Because we're going to combine negative 5x and x, minus 3 equals 2. I'm going to subtract 2 from both sides. So that's going to give me x squared minus 4x minus 5. So I want to factor this now, right? Because we're trying to find our solutions. So if we use our tree, that's negative 5 and negative 4. So that's going to be a negative 5 and a 1. So these become x minus 5 and x plus 1. So our solutions here, right, when we set this equal to 0, right, this whole time it's been equal to 0, that gives us x equals 5 and x equals negative 1. But is one of these an extraneous solution? So if we look back at our original equation, if we put a negative 1 in for x, if x equals negative 1, that's 1 over negative 6, that's fine. That's 1 over negative, or x over negative 4, that's fine. If we plug it in here, neither of those is 0. So x minus 1 is definitely a solution. But what if we plug in x equals 5? If we plug it in here, that's going to be a 0. So an x equals 5 is extraneous. So in this case, our only solution is going to be x equals negative 1. So another example here. We have 5x over x minus 2 equals 7 plus 10 over x minus 2. So common denominator here. Again, when I look at this, I see an x minus 2 and an x minus 2 and a 1. So my common denominator is going to equal x minus 2. So let's multiply each side by x minus 2. So we have x minus 2 times 5x over x minus 2 equals 7 plus 10 over x minus 2 times x minus 2. So on the left-hand side, those cancel out. We're left with 5x equals, and now we're going to distribute this, so we get 7 times x minus 2 plus, those cancel out, 10. So continuing to work this through, we have 5x equals, we're going to distribute 7x minus 14 plus 10. That's 5x equals 7x minus 4. We can subtract 7x from both sides. Gives us negative 2x equals negative 4. So divide both sides by -2. That gives us x equals 2. But we don't know if that's a solution, right? What if we plug this back up into the original? Well, that's going to make the denominator there and there 0. So x equals 2 is extraneous. And because that's the only solution we got when we solved, then this equation is going to have no solution. Now, we also could have looked at it from the very beginning. What is the domain here? X cannot equal 2, right? From the very beginning when we see that, because that would make it undefined. Okay, one last problem. So we have 3 over x minus 3 equals x over x minus 3 minus x over 4. So we have subtraction here. What is our common denominator? Our least common denominator. We have an x minus 3 and an x minus 3 and a 4. So my least common denominator, because what is this missing? This is missing a 4, this is missing a 4, and this is missing an x minus 3. So our least common denominator is going to be 4 times x minus 3. So we're going to multiply both sides by that least common denominator. So we have 4 times x minus 3 times 3 over x minus 3 equals x over x minus 3 minus x over 4 times 4 times x minus 3. So on the left-hand side, those common factors get canceled out. We're left with 12. Now, we have to distribute. So in that case, the x minus 3 is going to cancel out, which is going to leave us with 4x. And minus, right? We got to bring our minus down. Now we have x times this. Well, here the 4's are going to cancel out. That's going to leave us with minus x times x minus 3. So as we distribute now, right? We're going to distribute a negative x. That's going to leave us with 12 equals 4x minus x squared plus 3x. So let's get this all on one side. And as always, I like to have my x squared positive. So I'm going to add x squared to both sides. And then I'm going to combine these like terms. So that on this side is plus 7x. I'm going to subtract 7x from both sides. So that leaves us with x squared minus 7x plus 12 equals 0. So let's use our x. That's 12 over negative 7. So I see a, let's see, what are those factors? Negative 3 and negative 4, right? Negative 3 times negative 4 is 12. When you add them together, you get negative 7. So we get x minus 3, x minus 4 equal to 0. So when we solve that, we end up with x equals 3 and 4. So now we have to check, are either of these extraneous? Well, if we plug a 3 in, both of those become 0 in the denominator. So because of that, we know that 3 can't be an answer. So our solution, because if we plug in 4 now, 4 will work. So x equals 4 is our only solution. So I hope this helped you guys with the thought process. Tomorrow in class, we're going to work on some additional examples. And then we'll start our review for our Unit 4 test, which will be at some point next week. So I hope you guys have a good rest of the night, and I will see you tomorrow in class.